Hello everyone. In this video, we are going to see all about random forest algorithm. Before we get into the algorithm, we need to understand some key terminologies. First, we need to understand what is a decision tree. A decision tree is a supervised machine learning algorithm that uses tree-like model of decisions. It works by splitting the dataset into subset by applying a series of yes or no questions at each nodes. Decision tree consists of three components: root node, decision node, and leaf node. Root node is the starting point, decision nodes are the intermediate nodes, and the leaf nodes are the final outputs. We will divide the training dataset into branches, and the branches will be further segregated into branches, and we will continue until a leaf node is attained. For example, to decide whether to buy a phone, the tree might check its price, RAM, and the storage. The price of the phone is the root node. The RAM and the storage are the intermediate nodes. In other words, a decision node. The final decision is to either buy the phone or don't buy the phone. The decision trees are simple, easy to understand, and widely used for classification and regression tasks. The next terminology is bagging. Bagging can also be called as bootstrap aggregation. From our training data, we create different subsets of data. This is called bootstrapping. Next, we will train one model with one set of data. We will aggregate all the prediction and we will get the final prediction. For regression problems, we will take an average of all the prediction, and for classification problem, we will do majority voting. Random forest algorithm is a classic example for bagging technique. The next terminology is regression and classification. Regression and classification are two types of supervised machine learning problems. If we are making a numeric prediction on a dataset, we use regression algorithm. Regression model produces continuous output. Classification, in other words, is to make specific classification operation. Classification algorithm produces discrete output. One example for regression and classification is, with the current data, if you are predicting the temperature for tomorrow, that is an example for regression. We are making a numeric prediction on the data set. If we are predicting if tomorrow is going to be cold or hot, that is an example for classification. In classification, we make a specific classification operation. The next concept is overfitting. Here we need to know what is underfitted model, good fit model, and overfit model. If the model is too simple and fail to capture the pattern, it may lead to poor performance in the training and the testing data. If the model captures the true trend in the data, that model is a good fit or a robust model. If the model is too complex and if it fits even in the noise of the data, that model is a overfitted model. Now we will see what is a random forest algorithm. Random forest algorithm is an example of ensemble method. It combines multiple decision tree to improve the performance. Random forest algorithm uses bagging technique. It uses bootstrapping. That means that it divides the training data into different subsets and it trains each decision tree with one subset of data. Random forest algorithm uses random feature selection. At each split, it chooses a random subset of features and increases diversity and reduces overfitting. Random forest algorithm reduces overfitting. Random forest algorithm is more robust than single decision tree because it averages the result and lowers variance. Random forest algorithm works well for classification and regression problems. Here is our data with which we are trying to identify the fruit. One decision tree predicts the data as apple. Another decision tree predicts the data as apple.
And another decision tree predicts the data as banana. In this case, we are doing a majority voting and we are predicting the final output as apple. Here we are doing a majority voting. This is a classic example for random forest classification. Now let's see when we can choose random forest algorithm. Random forest algorithm works very well when the data is too noisy and it has missing values. We will choose random forest when we need an interpretable model. Random forest algorithm offers insights on feature importance, making it easier to interpret and understand the model decision. We will choose random forest algorithm when the data has many features. Random forest algorithm effectively process complex data. We will choose random forest when we need to reduce overfitting. By building a diverse decision tree and combining their outputs, it reduces the likelihood of overfitting to training data. We will use random forest when you need parallel processing. Random forest algorithm performs efficient parallel computation and speeds up the training process. We will see the practical implementation of random forest algorithm in the upcoming videos. I hope you got a fair idea of random forest algorithm and I am sure that you learned something new today. If you do like this video, please consider to subscribe and I will see you in yet another interesting video. Thank you.